Alright, so we are continuing on with trig. You already did the basics. You learned how to label opposite, hypotenuse, adjacent. You learned what sine, cosine, and tangent are. You learned how to write ratios. And today you're learning how to solve for missing sides. So you will have a test in a couple days. It's going to include the intro to trig and then the stuff from this module as well. So the first things we're going to go over are the actual steps. And these are the steps you're going to use when you're solving for missing sides. Step 1 is to find your angle of interest, and in these problems, it'll be the angle that's numbered. So it'll say like 27 degrees or 61 degrees. That's going to be your angle of interest. Step 2 is what you've already practiced and have already done. You're going to label your sides as O, H, and A. So remember, O is opposite, H is the hypotenuse, and A is adjacent. Step 3 is where things kind of change. You're going to only use the two sides with a variable or a number. Now, there are three sides to a triangle. Not all three of them are going to have something on them. So even though you label them all as opposite, hypotenuse, or adjacent, we're then going to cross out the one that doesn't have a variable or a number. Based on the two sides you have, of course, in reference to your angle of interest, you're going to decide on your trig ratio. So you're going to decide if we're using sine, cosine, or tangent. And step 5 is to set up your equation. And that looks something like you have the trig ratio, so it's either sine, cosine, or tangent. You're going to have parentheses, and in those parentheses is where you're going to have your angle of interest. So it's going to be a number in this case. And then it's going to be equal to your ratio of sides. And that ratio depends on which trig ratio. So if it's sine, if it's opposite over hypotenuse, cosine, adjacent over hypotenuse, or tangent, opposite over adjacent. You need to know that this ratio is going to include a number and a variable, because remember, we're using two sides and they're either going to have a number with them or a variable, x, y, z, something like that. And step 6 is to then treat this like a proportion and solve. You'll see what I mean in just a second. It's really important to know that with these missing sides, when you plug it into your calculator, you're probably going to get a long decimal. So with these ones, I want you to round to 3 decimal places. Alright, so I'm going to do 3 examples here, that way we can get some practice. So remember, step 1, I told you that we needed to find or locate our angle of interest. And I told you in these drawings, it would be the one that was the number. It's never going to be that right angle. So when I look at this triangle, there's only one that has a number, and that's this 72-degree angle right here. So this is my angle of interest. Step 2 was to then label our sides according to our angle of interest. So I'm going to start with the hypotenuse always, and it's across from the 90-degree angle. So I know this side length is my hypotenuse. The second one you should always label is the opposite. So I look at the angle of interest. I draw a line across to the side. That's my opposite side. And my third and final side, which is blank here, is my adjacent. Step 3 was to only look at the two sides with a variable or a number. So if you look here, this side has 15 with it. It's a number. We're going to use it. This second side has a variable x, so we're going to use it. But this third side, the adjacent side, doesn't have anything with it. So we are not using the adjacent side. So what I have left is the opposite side and the hypotenuse side. Remember, we have our SOHCAHTOA, so sine goes with opposite and hypotenuse. Cosine is with adjacent and hypotenuse. And finally, tangent is with opposite and adjacent. When I look here, I have the opposite side and the hypotenuse. So that tells me that I am using sine. Now, step 5 was to set up my equation. So I take my trig ratio, which was sine, so S-I-N. In parentheses, remember, that's where we're putting that angle measure. So sine of 72 is equal to, and remember, sine is opposite over hypotenuse. So I'm just going to write that so you can see. I'm now going to plug in what those sides are from my diagram. My opposite side, my O, is x over my hypotenuse side is 15. Now this is where we treat it like a proportion and solve. In order to do that, I need 2 fractions. So the left side, I'm going to go ahead and put over 1. Remember, when you cross multiply, we kind of draw these little circle oval things. So I'm going to multiply x times 1, and that just gives me x, which is then equal to, I do the same thing with 15 and sine of 72. All that happens is you put 15 in front of sine of 72. Once you work the problem and you have it to where it's x equals something, you can then plug it into your calculator. And we're plugging this whole thing in. So remember, if you have a little TI-36X Pro, you'll use that. Otherwise, you're going to have to go to that desmos.com and use the scientific calculator. You're going to plug in 15 sine of 72. And when you do that, you end up with x is equal to 14.266. Remember, we're doing 3 decimal places here, so be careful of that. All right, so this is a second example we're doing. Remember, make sure you are drawing these because it'll help you in the end. First step, I'm going to look at my angle of interest. I have it right here, 38 degrees. I'm now going to start labeling my sides. I know x is my hypotenuse. Draw that arrow across from my angle of interest, and I find my opposite side. And the third and final side is my adjacent. Now I look at all 3 sides. There's only one that doesn't have something with it, and that's this opposite side. There's no number, there's no variable, so I cross it out. I'm now looking at using my adjacent and my hypotenuse. So from my trig ratios, from my SOHCAHTOA, I know that I am using cosine. So I have cosine. Remember, inside the parentheses goes our angle, so it's 38 degrees. And remember, cosine is adjacent over hypotenuse. So now I'm going to fill in what I know from my picture and from what I've labeled. So I still have cosine of 38. My adjacent side, though, on my diagram is 12 over my hypotenuse is x. I can now treat this like a proportion, so I'm going to put the left side over 1. And I'm going to start cross multiplying. I have 12 times 1, which leaves me with 12 is equal to. And remember, this second one, you just put the number, or in this case, the variable in front of cosine. So x cosine of 38. Now, the last time we did one step and we were done because it was x equals. It is not x equals here. If we had something like 2x equals 8, in order to solve, we would divide by 2 and get x equals 4. We're going to do the same thing here. We're going to divide by whatever is attached to the x. So cosine of 38 is attached to the x. So what I'm going to do is divide both sides by cosine of 38. So the right side does it, the left side does it. What happens on the right side is it crosses out. It cancels each other out. And I'm left with x equals 12 divided by cosine of 38. Now, I look and see, is it x equals? It is. So you plug this entire thing right here into your calculator. When you plug it in, either in your own calculator, in the Desmos one, you end up with x is equal to 15.228. All right, so I've got this third and final example. So again, I'm going to mark my angle of interest, and I'm going to start labeling my sides. I know this is my hypotenuse because it's across from the 90. I draw my arrow across from my angle and find my opposite side. And I know that that third and final side is my adjacent, or my A. Now, I cross out my hypotenuse because it has nothing on that side. So I'm left with my opposite and my adjacent side. So that tells me I'm using tangent. So to start setting it up, I have tangent of my angle, which is 20, is equal to opposite over adjacent. I bring that tangent of 20 down. We didn't do anything with it yet. My opposite side here in this picture is 14 over my adjacent side is x. I turn the left side into over 1 so I can have a proportion and start solving. So 14 times 1 is 14, and that's equal to, remember, we just put x in front of the trig ratio. So x tangent of 20. Now I need to get x by itself, so what I'm going to do is I'm going to divide both sides by whatever is attached to the x. So I'm dividing both sides by tangent of 20. When I do that on the right side, it cancels out, and I'm left with x is equal to 14 divided by tangent of 20. Again, it's x equals, so we get to plug that into our calculator, and when you do that, you end up with 38.465. Now, this is it for the video notes. You are going to have practice problems over this, so make sure you work on that. If you have any issues, make sure you do request tutorials on Google Classroom, because this stuff will be on your test on Thursday.